In question 4, we are looking at a geometric sequence. So we've got a first term 0.64, second term 1.6, and the third term is 4. And in part A, we are asked to find the value of R, which is the common ratio. So to find the common ratio, remember we need to divide any two consecutive terms. So I could do U1 over U2 by U1, or U3 by U2, and whichever one I choose, I will end up with a value of 2.5. For part B then, find the value of S6. So remember this S6, the notation for this means the sum of the first 6 terms, and we can just use the formula from the formula booklet here, which is going to be our first term multiplied by 1 minus r to the power 6 all over 1 minus r, which, bearing in mind our first term is 0.64, is going to be 0.64 multiplied by 1 minus 2.5 to the power 6, and that's going to be divided by 1 minus 2.5, and that gives us 103.74. So we can say that is going to be 104 to 3 significant figures. In part C, this is the part that caused the most problems. We want to find the least value of n such that the sum of those n terms is greater than 75,000. Now, there's a few ways of doing this. Essentially, what we are trying to solve then is if we take this expression here, the sum we want is the sum of the first n terms is going to be greater than 75,000. The easiest way to do this, bearing in mind we have found what 2.5 is, what r is, and can plug that in here, is just first of all to graph 0.64 multiplied by 1 minus 2.5 to the power x, if you're going to put it on your calculator, all over 1 minus 2.5. And if you graph that, you'll end up with something that looks like this. You want to find where this becomes greater than 75,000. So on your second function, so this would be f1 of x on your calculator, and then up here you're going to put a second function f2 of x, which you're just going to put equal to 75,000, and you need to find, so analyze graph intersection, and you'll find that this point will be at about 13.2. However, we are asked to find the least value of n such that Sn is greater than 75,000. So the point at which it first becomes greater than 75,000 is going to be in the 14th term of the sequence. So therefore n is going to equal 14.